Fine. The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, good evening and welcome to today's webinar. Hope I'm audible to all of you. Can you please confirm? I hope I'm audible to all of you. Can you please confirm whether I'm audible? Thank you. So I could see some of the interns are still joining. Let me just wait for a couple of minutes, then we'll get started. All right. Let me share my screen also. And please confirm if my screen is visible. Yeah, thanks for confirming. All right. All right, so thank you for patiently waiting. Let me check whether recording is turned on or not. Yes, recording is turned on. Okay, so we can get started. Okay. Good evening and welcome to a different episode of today's webinar. I hope you've been attending the technical sessions delivered by Jayalakshmi in the past few days. And just wanted to check with you how it's going overall. How is the project sessions going on? Are able to make progress? Are able to learn many things from the internship? Quickly, just wanted to check. Okay, so I could see a few responses. Yeah, good evening, everyone. So how is the internship project going on? Are you able to understand and build? Yeah, So yes, okay, I'm getting many responses saying that yes. Okay, good to know. Right. All right. Yes, here we are learning. We are making progress. Okay, good, good. Okay. All right. Okay, thanks. I think okay, some of you are telling we are learning. Yes. Okay, good evening. Okay, yes, nice. Okay, understood, but not perfectly. Yeah, that is perfectly understandable. It's a slow process, right? Easy to understand the concepts. Okay, getting good responses. Okay, it's good. It's really good. 100%. Okay, good. Okay. All right. So thanks for sharing your feedback about the internship. Let me set the context for today's webinar. I hope you got a message from our team about this special episode of the internship session. So my name is Mubin and I work as a technology head at Emertxe. And today's topic is a deep dive into industry applications of embedded systems, IoT and beyond. So idea is that you've been doing this internship and most of you will be curious on understanding in-depth view of how actually embedded systems and IoT looks like from the internals, from the use cases, as well as many of you will be aspirational to know what are the career opportunities available in embedded and how you can basically leverage your current internship into a full-fledged career program for you, right? So I'll be addressing a few important aspects related to how embedded systems and IoT look from internal perspective and also talk about the scope of it in terms of how industries use it and discuss about the career roadmap and see what you can do in terms of uh, learning and having a focused approach on building a career in embedded systems and IoT. So let me walk you through the agenda quickly. So we'll discuss why embedded systems and IoT matter first of all, right? This is something which everybody will have a question, right? In the world of AI, in the world of engineers who are focused on learning subjects related to computer science, robotics, etc. Right? Why embedded systems and IoT matter, right? This is something which we can discuss. And what falls under embedded systems and IoT. So we should know what all things are part of the embedded systems and IoT ecosystem. So I'll talk about that. Then real world impact, applications and domain. I'll basically talk about what is the real world impact of how basically embedded systems and IoT are applicable in different domains and application areas. Then I'll take two specific use cases in automotive and wearables, discuss about those specific use cases in automotive industry and in wearable tech. Then going forward, we'll see what are the technology stack which are part of the embedded systems and IoT portfolio of things, right? So we'll discuss about what each levels are and what is part of each level, how basically you can navigate and learn those technology stacks and how it's relevant to the industry as well. Then going forward, we'll see what is the career roadmap, right? So we'll discuss about career roadmap for you. So especially for a junior engineer, you might not have clarity in terms of what are the possible basically job roles available in the industry and what industry wants, right? So we'll discuss about those things. And following that, what next, right? This is an important question which everybody will have in your mind, right? So you complete an internship, what next? You come, then let's say you want to build a career, right? How do you basically step your shoes and incrementally build your skills so that you can become a potential embedded software or IoT software engineer? If any questions related to basically embedded systems and IoT roadmap as well as career roadmap, feel free to ask. I'll be happy to answer your queries. So this is going to be the agenda for today's webinar. Please note, this is a specific dedicated session we are having, and going forward, the internship project related sessions will continue and Jayalakshmi madam will be continuing those sessions. All right. Live is not started in YouTube. I think we should be starting it. Let me just quickly check. Yeah, since you are here in go to webinar, should have been started. Let me just quickly check. Just pinging my team member to check whether YouTube live is on or not. Okay, we are just checking. Hold on. Okay. Yeah, it's live, it seems. Okay, should be able to access it. No problem. Okay, so some of the questions related to offer letter I may not be able to answer now. Okay, you can post in the discussion forum. Okay, so this is a dedicated session with a specific agenda. All right. So let's get into the topic one by one, right? So why embedded systems and IoT matter? This is a common question that people have, right? So important thing to understand is that how is it relevant in the current market, right? How basically embedded systems is playing a catalyst in terms of driving the industry, right? So if we see embedded systems growth, right, in the industry, so it is embedded system is quite a vast area, right? It's everywhere around us. Embedded systems power smartphones, it powers appliances, it powers wearables, right? They operate silently in the background, enabling automation and control, right? So if you look at the massive growth in the IoT industry, right, you can see over 75 billion connected IoT devices are expected globally in the year of 2025, right? So that's kind of a huge projection what you have. So it's embedded systems is everywhere around us, right? We can see on a day-to-day basis, we're using smartphones. If you go to your home, you're using home appliances, your smart washing machines, right? We have cameras, we have smart TVs, right? And we use it in multiple basically household equipments. And for example, if you look at a vehicle, right? So we have so many basically embedded devices talking to each other. For example, you have we call this dedicated system called as ECUs, right? We have infotainment systems, we have the dashboard, we have basically systems to basically like for driving the powertrain, we have systems to basically run the ABS system and so on, right? So if you look at a car, it is a complex set of embedded systems controlled mostly electronically, right? Similarly, massive growth of, if you look at the massive growth in IoT, over 75 billion connected IoT devices are expected globally. It's a huge, basically, number of basic devices connected. It's used in smart homes, factories, cities, healthcare, everything relies on IoT. And in terms of industry growth, global IoT market project is to exceed around $1 trillion, right? So that is the kind of basically growth in the industry you can expect in terms of embedded systems and IoT industry. So what it translates to is that there is a strong demand for engineers with hardware and software skills. Right? So it's not just that we are seeing a demand in the IT industry or we're seeing a demand in the AI industry. Strong demand for engineers are there with core embedded skills, which includes hardware interfacing as well as software skills. and carry relevance, right? This is also something which matters for you. Embedded systems and IoT engineers are in top demand, right? So many a time, right, we see that when you get interview opportunities in campuses, it may not be the case. The visibility of having embedded job roles, right, may not reach to, right, many of the colleges. We see companies hiring for the IT sector, but we don't often see that companies visiting uh, colleges for core skills. But in fact, there is a high demand in embedded systems and IoT among top tech roles. The reason why companies don't visit many campuses is that they are not finding the right talent, in fact, right? So they need specific skills what many of the graduates lack, and only top colleges may they visit and hire candidates from those colleges, right? So opportunities are there across multiple domains, including automotive, healthcare, robotics, and AI. So please note, several basically verticals are there, including automotive, including healthcare, including robotics, and AI as well, right? So AI is also included in the embedded systems and IoT roadmap. So discussing about uh, what falls under embedded systems and IoT, right? So when you talk about embedded systems and IoT, primarily, right, we can categorize into different segments, right? One is, for example, core hardware related skills. When I say core hardware, one is the hardware design part of it, right? We are not talking about hardware design here. We are focused on hardware interfacing part of it, right? So one area is that we can very well work on the hardware design and creating new basically boards, new basically circuits, new SOCs, etc. There is a different basically subdomain itself. Here we're focusing on embedded software design and development. So when you want to basically know about embedded systems and IoT from an embedded software engineer's perspective, right? It is more than just coding microcontrollers. Many people think, okay, we can just take one microcontroller like Arduino based system and I can just program it. There is embedded systems. That's something beyond that. Modern embedded system landscape span from like bare silicon to cloud intelligence, connecting physical world to the digital dream, right? So it's not just about writing some fancy program using Arduino, maybe programming the GPIOs and doing something, right? Something beyond that. So here, when you talk about hardware core, microcontrollers and SoC comes into picture, you should know about the architecture. You should know how to basically perform interfacing with sensors and actuators, right? You should know basically how to configure the timers and ADCs, etc. That comes in the core hardware part of it, right? Right. So that is one thing, right? So core hardware is one area. Secondly, when you talk about programming and controlling the software, we can do it in many ways. One is bare metal programming, right? This is something which will be fundamental to the embedded microcontroller programming skill set. Second is, right, we can use something like RTOS, wherein we can use RTOS, it's like free RTOS, Zephyr, etc., to build more complex applications. And thirdly, to even build more advanced application, we can use something called as embedded Linux, right? So talking about firmware development. So firmware development we can do at three different levels. One is bare metal programming, second is RTOS, and third one is embedded Linux, wherein you can build more complex application. For example, you talk about free RTOS. If you look at take an automotive like application scenario, there are ECUs which run free RTOS also. There are ECUs which run, for example, systems also run embedded Linux. For example, your infotainment system and dashboards, right? They may run embedded Linux, whereas other critical systems will run RTOSes. Similarly, talking about connectivity. So nowadays we deal with embedded systems that are connected to each other. We connected to the cloud, etc. So connectivity plays an important role in embedded systems, right? So we may have to basically learn about wired interfacing. For example, UART, SPI, I2C, CAN. These are popular basically wired protocols which are used to connect devices and exchange information. Then we also have basically wireless connectivity based protocols like Bluetooth, Wi-Fi, LoRa, etc., which can be used for short range as well as long range communication. Right? For example, Bluetooth may be used for like communicating something which with your smart devices like a smartphone or a mobile phone, etc. Similarly, Wi-Fi can also be used. Whereas if you want to have long distance communication, let's say you want to build an automated drone for agricultural like farming, etc., then you can go for basically technologies like LoRaWAN, which has a longer range. Similarly, other basically connectivity, basically technologies like cellular IoT, NB-IoT, LTE, etc., can also be used. And apart from hardware, firmware, and connectivity, this is where AI comes into picture. Right? So many people ask, okay, is there a connect between AI and embedded system, or is there a different domain that we have to focus on other than embedded systems and IoT? Right? So please understand that AI is an augmented technology which applies everywhere. So we have to know the fundamentals of the domain, for example, embedded systems. Along with that, we can basically leverage AI also. So in terms of AI, AI can be used on devices. We call it as edge AI. AI can also be used on the cloud, right? So here we have like when you talk about edge and beyond, embedded systems can use edge AI to perform the processing at the edge level. For example, we go to a factory, right? In a factory, there are many devices, and these devices will go through wear and tear, right, very often. So when you talk about edge AI, you can have intelligent AI-based systems built into the device so that whenever the device undergoes wear and tear, it will report to a centralized basically system where the necessary basically action can be taken by the maintenance team. Right? So machines undergo wear and tear. AI-based systems can be built for something called as predictive maintenance. And the advantage of using edge AI is that instead of basically having the AI system built into the cloud, which requires a lot of basically bandwidth and connectivity, we can build the intelligence into the edge system itself. So along with that, when you talk about IoT-based devices, we should also know about security and encryption. For example, hackers, let's say they hack into one of the basically embedded IoT-based device, they can control all the devices if they find a similar basically security loophole. So security and encryption is also part of basically embedded systems and IoT, and OT updates and device management also comes into picture, right? We have hundreds of thousands of devices, right? We should be able to, for example, patch it if there are security updates or any updates, right? You should be able to patch it. For example, take the example for mobile phone. So mobile phone have OT updates, right? And whenever you want, you can basically push notifications to the user and get the updates done. Similarly, nowadays, if you look at cars, you take a Tesla or even a Mahindra car, right? You can update the software using OT updates, which is also available. So overall, this is what falls under basically embedded system landscape, and it's important that we understand and have this bigger picture in mind. Okay, so I'm getting some questions. Feel free to post those questions. I'll pause at a later stage and take those questions and try to basically answer them. Okay. So talking about applications and domains. Uh, so as such, embedded systems in terms of the core concepts, right? These the slide which I displayed applies, right? So this is kind of a generic approach you can take in understanding what falls under embedded systems. But it applies to several applications, industries, and domains. For example, when you talk about automotive systems, right, what are the applications that comes into the mind? Nowadays, cars have something called as ADAS, and even modern cars comes with autonomous driving, right? So ADAS is a feature which is nowadays integrated almost into all of the cars, which helps in assistive basically driving. For example, right, we've seen instances wherein many time we are distracted, right, and we look somewhere else, and some obstacle, another car comes into your pathway. Then there are ADAS systems will automatically engage the brake so that you don't basically hit the other vehicle, etc. Right? Similarly, in automotive domain, you have ECUs and engine control units. ECUs are specialized microcontroller system which control different basically controlling units inside a car. For example, let's say you want to control your power windows. You want to basically, for example, implement a system for the powertrain. You want to basically have a sensor which basically monitors the engine temperature, right, etc. All this information will be driven using something called as ECUs. And all these ECUs will exchange information using a CAN bus, right? Most of the ECUs will exchange information using CAN bus. So you have information coming from different places like temperature coming from the engine, right? Fuel levels coming from basically different sensors. You have basically climate control systems. You have the basically lighting systems, etc. All this information will be shared from different ECUs, and they need to be diagnosed and displayed often onto the dashboard. So CAN bus comes into the picture, right? So this is one area where embedded systems applies. Similarly, you have consumer devices, wearables and smartwatches, right? These are application areas of embedded. Home automation systems, audio video processing systems. For example, you take a smart TV, right? You take, for example, a security camera, etc. Audio video processing comes into picture. Right? Similarly, in industrial IoT and IoT industrial systems and industrial IoT systems, we have PLCs and automation devices. Predictive maintenance, as I told you, right, is part of the industrial automation. Robotics and motor control, right? So this also comes under industrial, basically automation, and here also robotics, AI, etc. comes into picture. So what I want to tell you is that there are many applications and domain which impact the real world, which are related to embedded systems. It could be healthcare, wherein we have patient monitoring systems, right? We have portable diagnosis devices, energy basically monitoring systems like smart meters and grids, EV charging systems, solar inverters, right? We have in the energy segment. In aerospace and defense, for example, you have these avionics systems, right? UAVs and drones. Recently, I happened to visit IIT Madras, and they had showcased some of the UAVs and drones, uh, wherein we have this Make in India initiatives, wherein India-based companies are manufacturing drones, coming up with basically several applications related to UAVs and drones, secure communications, etc. So there are many domains related to embedded systems and its applications. Once we learn these skills, we can very well get a job in any of these industries. All right. Okay. So just wanted to share two use cases related to automotive and wearable from a technical perspective, right? So I just wanted to show you. So one is the automotive dashboard, which is a critical real-time display system on your vehicle, right? So in terms of building an automotive dashboard, yes, there is a complex architecture which goes behind it, right? Let me take a simple example of a temperature and fuel sensor, right? So if you look at uh, one of the important basically information we need to display on the dashboard is that the fuel level as well as the engine temperature, right? If you look at any instrument cluster on modern cars or any basically car, you will find that fuel level is displayed as well as the engine temperature is also displayed, so that any basically action needs to be taken by the driver, he can take it. For example, fuel level is low, for example, that will be an indicator, you can take an action, right? So what typically happens is that these sensors, right, will periodically sense this information and send the information to something called as an ECU, right? So ECU will process the information which comes from several sensors, right? And this information from the sensor comes via ADC, right? So analog to digital converter will be used. So you have to sample these basically values from these sensors, and those values will be processed by the ECU, and so that the values are displayed onto an instrument cluster using a GUI, we can use something like a CAN bus protocol, right? All right. So here you can see there is a sensor to EC communication happening, right? And then ECU is going to send this information to the instrument cluster, right? So here we use a protocol like CAN, which is generally used in automotive industry to exchange information between ECUs, right? Now, when you're talking about CAN communication, it's a reliable priority-based messaging protocol used between nodes, right? And the information should come real time, right? So this information, whatever you want to display, which should come in real time. And there are basically tools, diagnostic tools, which can be used by mechanics to check fault tolerance, right? So this was an automotive use case wherein we are using embedded systems, right? This is embedded systems. We're using certain protocols, right? We're also using real-time systems, etc., to build a automotive level dashboard. So that's one thing. Talking about the next use case, which is a smart wearable device, right? So some of you may be using a smartwatch or a wearable device, which will help you to basically get health information, right? It also displays some vitals, etc. Right? For example, you have heartbeat getting displayed, right? Even the modern, basically, smartwatches which come from Apple will have information related to, for example, your blood pressure. Right? It has like capability to detect your sleep patterns. Right? You can use it while you are jogging. Right? So a lot of information, right, we'll get from these smart devices, right? But underlying that, we have to understand what goes inside these smart watches and devices, right? So if you look at the data flow of a smartwatch, right, wherein you want to display some information about your vitals, we'll have sensors, which could be PPG or IMU sensors. These sensors will send this information using a protocol like I2C. Right? So sensor will send this information, and the microcontroller can get this data from this sensor using I2C protocol. So what I'm trying to highlight is that there are several things involved in building real-time embedded applications. From application to application, the nature of basically system flow will differ, but overall, having a bigger picture is important to build any embedded system. So for example, here we saw that there is a sensor, there is a microcontroller, right? But the interface is what? ADC. And this ECU may be running a real-time system. Right? And here, for example, you're going to display something onto the dashboard, again using CAN protocol. So this is a different architecture. Whereas here the architecture is different. We are having basically sensors which are connected to the MCU and communicating using I2C protocol. And same information, you can send it to the phone app. This communication can happen through Bluetooth, BLE, right? And this phone can again get synced to what? Your cloud for further analytics, storage analytics. Right? So what comes here, right? You have I2C protocol, you have Bluetooth for wireless communication, you have cloud sync using, for example, your Wi-Fi, right, or the internet, etc. You may use protocols like MQTT for sending the data and so on. So overall, we can see like we have to understand about communication using different wired and wireless sensors, right? We have to know about sensor fusion. Multiple sensors are there. For example, you may have a combining accelerometer will be used, gyroscope can be used. For example, you want to detect fall, right? We're jogging. You want to detect basically how many steps you're taken. So you have a sensor, right? It's an IME sensor based upon accelerometer and gyroscope. These sensors can send this information. You can display it and capture it and send it to the cloud also. So I just wanted to show this use cases, trying to tell you that different applications will use different technologies related to embedded systems. And for you to build such a system, a complete end-to-end understanding of how embedded systems can be built, what protocols can be used is important. Okay, just wanted to highlight that. All right. Okay. So moving on. So I think some of you are asking questions. What are the skills required to learn embedded systems? Okay, speak something more about this. This is Monisha saying, what are the skills to be learned for embedded systems? Then we have Panindra Verma asking, so speak something more about firmware development opportunities. Okay, I'll talk about it. Firmware development. All right. Then some people are asking about how many days course, embedded system course is there. Okay. I have a strong skill set in AI and IoT, so can I work as AI and IoT engineer, etc. I'll be answering those questions. Okay, let me just talk about some more things related to this, then I'll take those answers. Questions. Right. So this is one way of looking at the technology stack. Okay, again, I'm not telling that we have to learn everything, right? This is kind of a broader picture. Just wanted to give you, for example, when you talk about web development, they say there is full stack web development, right? Similarly, in embedded and IoT, there is also a technology stack which can differ from project to project and domain to domain. Just trying to share a broader architecture overview and technology stack for embedded systems and IoT. So at the bottom of the stack, right, we have this hardware core, right? That is something which is there at the bottom of the stack. So when you talk about embedded system development, microcontrollers, right, MCU, is the heart of the embedded systems. Again, in microcontrollers and microprocessors, there are many variants here, right? When you talk about MCUs, right, there could be 8-bit, 16-bit MCUs. There are 32-bit MCUs. There are 64-bit MCUs, right? So the one which you're using in your internship is, I think, an 8-bit controller from PIC, right? And there are other similar 8-bit controllers available. 32-bit, for example, we have controllers from, right, ARM. For example, we have ARM based controllers. We can use ARM M3, M4 controllers, right? Which example we have STM32, right? Then we have 64-bit controllers coming from several manufacturers, again ARM-based controllers, right? Qualcomm. Right? We have controllers from, right, different companies who manufacture ARM-based controllers, right? So hardware core, when you talk about hardware core, using these MCUs, right, we should be able to develop an embedded system. So for that, you have to know certain aspects with respect to the architecture of the microcontroller, interfacing, right, sensor interfacing, right, etc. So here we have just highlighted some of the things we should be familiar with in terms of technology stack. One is the sensor interfacing, right? Second is basically knowing how to interface using GPIOs, ADC, tags, etc. Then when you talk about right, certain devices which are battery powered, like a smart watch, etc., then power management also comes into picture, right? So you should know how we can basically optimize the algorithm so that it does not consume more of a power. This is where power management comes into picture. So having a good understanding of the microcontroller architecture, about the interfacing, right, about the protocols, helps you uh, get started with the core of the hardware interfacing part of it, right? That's one thing. Secondly, when you talk about the software development part of it, right? Yes, these are interconnected, right? So when you want to develop a firmware or a driver for a hardware, you should have the knowledge about the hardware, plus you should know how to interface it. And for that, you should also know programming languages, right? Which programming language to use. So C has been, in terms of programming language, C is one of most commonly and preferred programming languages because of several reasons, including because it can help you develop efficient programs, right? I think this might already been discussed in your internship sessions, right? So when you write a C program, it not only helps you to access the hardware, but eventually the program which you built will be very efficient in terms of basically execution speed as well as memory consumption. So apart from C, we can also use C++ to develop embedded systems. Rust is not yet there, right? Slowly, I think Rust also is getting used in writing embedded firmware, right? So any questions so far? In this? Okay, somebody is asking questions related to robotics. Yeah, so Ganesh is asking, C language is necessary? Yes, C language is very much required for you to basically program embedded systems. That's a foundation, right? Companies may or may not use C, but it's important that when you start developing and learning to build embedded systems, C has to be there in basically building the drivers and building the high level libraries, etc. C will be used very often, especially if we're going to work on the firmware side of it. Maybe when you're working on high level applications, then other languages like C++, etc. can be used as well. Okay, so some people asking, can you give some tips how to prepare embedded system base core companies? Yes, I'll talk about it shortly. Okay, so when you talk about firmware development, I hope you understand what is this firmware development means, right? Some of you are having this question. Right. So can you tell me what is meant by firmware development? Is it same as embedded system development or is it something different? What do you understand by firmware development? Can you tell me? Hmm? According to you, what do you understand? What is firmware development? Whatever you know, you can answer. Yeah, I think I'm getting some answers. Software interface, hardware, and the user. It's like software rich with control hardware components, Sindhuja says. Then I think Jaya Prakash says, I think bridge to software and hardware. Firmware is the middleman between hardware and the software. Okay. Please explain, okay, where we can process the most. Okay. Tells how the software works, says Dhananjay. It's a software. It's a firmware development in general or something specific like tools, languages, writing low-level software for hardware, right? So when you say embedded software development, right, so often you heard the term, right, firmware development. So when you talk about firmware development, we're telling mostly about low-level development of the embedded systems. It could be developing the drivers. It could be developing the board support packages. It could be developing the hardware abstraction layer libraries, and to some extent, low-level applications also, right? That is what firmware development is about. Mostly, when you talk about application programming, some people try to separate, okay, embedded software application development from firmware development. But many people refer to it as, okay, right, basically low level, basically embedded system software, we call it as firmware. So when you talk about microcontroller programming, in fact, you are doing firmware programming only. Okay, so next comes communication protocols, right? So we know how to basically program the hardware. Here, for example, learn how to program the hardware, how to program the microcontroller, right? So what is required here? Yes, programming skills are required, right? And microcontroller knowledge is required. Interfacing skills are required, right? Protocol knowledge is also required. Right? Wired wireless protocol knowledge is also required. So that's why this comes into picture, right? When you talk about communication protocols, for data exchange, right, we have to learn some high level basically protocols apart from the basic protocols. Like for example, if you want to exchange a lot of information between device to device, right, or device to cloud, etc., a device to gateway, or device to cloud, etc., then we may have to use any of these protocols, which is like MQTT, right, which are used for communicating between gateway to cloud or device to cloud, right? Similarly, for wireless communication, you can use Bluetooth, right, Wi-Fi, etc. CAN bus, mostly used in automotive industry. Right, LoRaWAN, as I mentioned, for long range wireless communication. Right? So these are some of the things which you have to know as part of the technology stack for developing embedded systems. Next, right, let's say you know low level basically programming here, right? But at times you may end up wanting to create a more complex embedded software ecosystem, right? Embedded software, right? It could be anything. For example, let's say you want to design a automotive instrument cluster. Right? Or let's say you're developing a firmware for your Wi-Fi router. Right? I'm just taking two examples. Right? So here, if you look at an automotive instrument cluster, typically it runs embedded Linux. Or it may run an operating system like QNX also, right? Several other choices are there. Similarly, Wi-Fi routers, example, using an Airtel Wi-Fi router, etc., right? It runs embedded Linux. So you can use operating system to build more complex applications because of several reasons. Because these operating system already provides the board support packages, device drivers, right, and some of the libraries which are available, and the application logic is something which you have to build. So having a knowledge about operating systems is very much essential nowadays to build more complex applications. So it could be embedded Linux, it could be FreeRTOS and Zephyr, both are open source RTOSs, right? And there are other things also, which is something which we can learn at a later stage also, right? Using Docker, using Edge.ai, etc. These things also will help you in building more complex, advanced applications. Right? Okay. Let me know any questions in this. Okay. And the last thing, if you want to basically build applications which are connected, Okay, so applications which are connected. So for connectivity, right, for storage, for AI analytics, right, etc. We can send the data which comes from the MCU, right, from the devices, right. This data can be sent to the cloud, right. So on the cloud server, several things can happen. You can store the data. We can, after storing the data, we can perform AI analytics, right. So here analytics comes into picture, right. So you may have to, you can use either machine learning algorithms, right, for deriving insights, or you can run simple algorithm, for example, to take some actions in terms of alerts, right, etc. So for that, there are several cloud providers like AWS IoT, Azure IoT, right. You can use open source IoT tools also. You can use it for deployment. We can use basically device management. For firmware updates, we have to use OT updates, right. For uh, DevOps, right, we can use CI/CD pipelines, right. For dashboards, for displaying basically information related to the sensors, nodes, etc. We may have to come up with custom dashboards. So overall, this is what a technology stack looks like. If you want to have an end-to-end view of what is required to build an embedded system, this is what really matters. Okay, so have this in mind. And definitely, if you want to build a career in embedded systems, these are the areas which I want to focus on. Now, people may ask, okay, do I have to learn everything? May not be necessary, right? So there are certain things which are very important, and each of these, what do you call, levels, right? It's not necessary that you have to learn everything in this, right? So keep that in mind. Okay. Okay, I'm getting some questions. Let me just quickly check what those questions are. So someone asking what are the skills required to get into embedded systems? Okay, I shared some of those. Maybe I'll share some more in detail. Okay, so please keep posting the questions. Basic knowledge and skills required to join a company. How long will it take to learn about embedded systems? Okay, these are some common questions I'm getting. Is it necessary to learn bootloaders to get into industry as a fresher? Okay, okay, I'll answer those questions one by one. So Mateshwaran, sorry, Matesh Verma is asking, is it necessary to learn bootloaders to get into industry as a fresher? It depends on what level you should know, right? You don't have to know how to write a bootloader. It's not necessary, but you should know how an embedded system boots, right? And many a time what happens is that some people in your team will be either developing the bootloader or customizing a bootloader. So many of the job roles may not be related to bootloaders, but there are certain job roles which are related to bootloader. So having high level knowledge of bootloader is essential, but it's not necessary to know how to basically program it from scratch, right? But when you talk about bare metal programming, which I'll be discussing, at times what happens that you'll write something called as a startup code, right? And startup code will have to do some initializing, etc., which you should be familiar with. So Livingston is asking basic knowledge and skill required to join a company. Okay, I'll talk about it. Okay, how long will it take to learn? Okay. Right. So in terms of career roadmap, cannot complete. This is not a complete picture, right? So importantly, okay, I just mentioned some of the like very important things, right? So first thing is master the basics. So what is basics? Learn programming like C, C++, right? Then possibly get to know about an overview about microcontrollers, right? So that is the first level thing. C, C++ you have to master, right? Then an overview of microcontroller architecture, etc. is important. What is embedded systems, etc. you should know. Then comes the foundation part, wherein you actually get deep dive, right? You do a deep dive here. So here you have to write something called as drivers, HALs, right? Which is and comes under microcontroller programming and firmware development, right? So once you complete the programming, right? Second thing will be microcontroller programming, part of it, right? Third comes, and here also you can learn something called as data structures, right? Post that comes, for example, operating system and RTOS. So as I mentioned earlier, if you want to develop more complex applications, then you may have to learn things like Linux, RTOS, etc. Debugging skills are also required, right? So C, C++ is essential. Similarly, basics of Linux will also help. So after RTOS, what next, right? So there are again specializations you can do depending upon embedded systems or IoT, right? So you can get into like operating system internals. You can learn about like build systems like build root, right? In IoT, you may have to learn programming languages like Python, right? We may have to learn things related to IoT protocol, cloud interfacing, and so on. So you have several choices. One is the foundation part of it, basics. Then comes basically specialization. Specialization can be in embedded systems, specialization can be in IoT, and specialization can also come in edge AI and etc. Right? So whatever you're doing, importantly, right, you learn the core skills. After learning the core skills, you have to show the projects. So typically we say that for every core module, right, you can work on 2 to 3 core projects. For example, in C, you can do 2 projects. In microcontrollers, you can do 2 projects. In data structures, you can do 2 projects. OS, RTOS, you can do projects, etc. So build the skill, learn the skill by implementing projects, right? So these projects you can showcase in your resume. And by doing that, companies will get visibility in terms of what skills you have. And they will also be able to build a trust saying that, okay, this student has learned these skills, not just learn skills, but also have completed the project, which will bring a big value add in terms of basically building a trust. And by doing that, you'll also get opportunities in good companies, right? Apart from that, as I mentioned, specialization can be in embedded Linux, specialization can be in IoT protocols, specialization can be in edge AI and ML also, right? And other things also is that becoming job ready, right? So when you say becoming job ready, you have to showcase your portfolio, right? So how do you basically showcase your portfolio to the clients, right? So build a good social profile. You can update your projects in GitHub. You can update your resume with all the projects and skills. Right? Update your LinkedIn profile. So these things will add value in terms of showcasing to the companies. Portfolio, right? Portfolio building you're doing, right? Then many times what happens that, okay, we may assume that we have learned many things, but somebody should validate, right? So how do you validate? You can ask a technical, basically expert to take your interview, kind of a mock interview. right? So this will also validate your technical skills are right, your communication skills also will get evaluated here. Okay, so kind of a very high level roadmap from fundamentals to job readiness, right, at a high level. And typically to build this kind of a skill as well as project, usually it takes around 6 months. If you spend dedicated, full-time focused, you can learn these individual skills, you can build projects and build your portfolio and become job ready, right? So that is what I would recommend for your career roadmap. All right, I hope I answered some of the questions some of you asked. Okay, so one very interesting question from Karthik. Okay, so let me just read those questions. So to get into embedded system, should a person know all the microcontrollers? Okay, so it's a great question, right? Or which microcontrollers you should know? All, right? Yeah, it's not necessary to learn about all the microcontrollers. It's not possible also to learn all these microcontrollers, right? But generally speaking, right, you may want to get started with bare metal programming. Right? And this bare metal programming can be done either on an 8-bit, 16-bit, or even on a 32-bit system. Right? And you have several choices. For example, you can do it using PIC microcontroller, right? Using 8 and 16-bit. You can even do it using 32-bit. For example, you can take an ARM-based controller. Right? So either one is fine, I would say, right? When you're doing bare metal programming. So ARM is something which is becoming quite popular now, right? So yes, having a core skill in PIC and ARM or ARM is sufficient, I would say, right? You don't have to know about all the microcontroller programming. Similarly, when you talk about right, OS-based programming, right? When you do OS-based development, yes, you can use a microcontroller which is either 32-bit or 64-bit. Again, ARM is quite popular now. You can use ARM-based controllers to program this, and this can be done using Linux or an RTOS like FreeRTOS. Right. So hope I answered your question, Karthik. Yeah, and yeah, you have other controllers, for example, ESP32 is also available, right? These things will help you as well. For example, ESP32 is low cost, it has wireless connectivity, and you can use it to learn basics of microcontroller programming also, but it's not essential as such. You don't have to learn everything, right? So that's why I told you, right? You can have choices. You have to make a choice. It's better to master one than becoming a jack of all initially, right? So pick one. For example, you take, for example, ARM M3 or M4, try to master it, right? So that is sufficient. You can do RTOS programming also on that, RTOS based application development. Then you can move to a basically Linux based system and do embedded application development on that. Yeah, Siddharth, so microprocessor important to know or microcontroller is enough? Yeah, microcontroller is what is important, right? So when you say microprocessor, yes, you should know the difference between both, but essentially you'll be using a microcontroller or an SoC which has a processor in it to build embedded system applications. Karthik, if I mastered any one of the MC, will it help? I think I answered, right? So I told you it's good to have uh, familiarity with 8, 16, 32-bit, any one of these basically, then you can have exposure to 64-bit controllers also. Okay. Is there any hardware dev kit required to learn embedded Linux? Yeah, that's also a good question, right? So some people are asking about the development tools. Right? Okay. 1 second, what happened? Yeah. So in terms of basically development kits, right? Dev kits. Right. So here at Emertxe, if you see, right, we are having two things. One is uh, when you talk about bare metal programming, using PIC-based kits development board as one of the boards which you can use. We use something called as a board from Rido Labs. Right? This board is available. And secondly, right, there are several other boards which are available. You can use PICSimLab, right, simulator to use any of the boards available. So here, please understand, board does not matter much. The controller matters, and peripherals which interface will help you to basically do several basically programming applications using it, right? So many boards are available for a given microcontroller like PIC. You can use any of those boards and program it. In our basically courses, we typically use a board from Rido Labs, which has several peripherals including CAN, I2C, SPI, GPIO, UART, LCD, LED, etc. Right? That's one thing. Then ARM-based basically kits are also available. So there are many options. Right? So generally preferred and commonly used boards controllers are STM32 based controllers. Right? Most of you would have heard about it, right? Again, here several options are there. Nucleo boards are there, discovery boards are there, etc. Right? So in our case, we are like ARM-based 32-bit controllers. We can use like discovery board. Right. So it's something which we are planning to use. Right? Discovery board is used. STM32 discovery board is used. Again, there are several variants are there. You can pick which one it is. Apart from this, for like IoT-based application development, right? Many people prefer ESP32. This is absolutely fine because you can do rapid prototyping using wireless technologies. Right? You can use it. Okay. Okay. Then for high-end basically application development, yes, you can use 64-bit ARM controllers. We can use something like Raspberry Pi or BeagleBone boards, right? These boards you can use. Hope I answered your question. Vijay Karthikeyan, sir, I recently have participated in Smart India Hackathon 2025 final, and so I'm interested in creating project from scratch. What job role position do you recommend? I think I already talked about it, right? So creating projects from scratch, job role, there are several options. It's your personal interest. Okay, you can take any of the domains, application areas we can focus on and start working on. It could be automotive, it could be wearables, it could be right smart home, smart cities, right, agricultural automation, AI, edge AI, etc. Right, it depends on your interest area. Right, you have to choose. Neeraj Kumar, is this internship will be enough for industry ready job, or what should extra things to learn? Right, so internship, since it's for 1 month, yes, you are focused on building a single project using microcontroller, which is PIC, right? And C, for example, we covered for 1 week, and microcontrollers essentially we covered, and you're building one project, right? So beyond that, many other skills are required generally to get into a core company, right? Yes, internship is a good start, but whether you can crack an interview is something which is not predictable as such, right? It may not be possible to get into good companies. So moving on, okay, let me just write industry expectations. So I just highlighted some other things. Not everything is important, right? So junior engineer versus senior engineer, some other things will change, right? So I would say not just strong C skills, right? Strong technical skills are required, right? Including C, C++, data structures will be there, right? This is something which is very important for you to have. All the subjects which I mentioned earlier, this is technical skills. So apart from technical skills, right, debugging proficiency also matters, right? So the issue, right, with any software system is that you will come across bugs, right, and you will come across situations wherein things are not working. It was supposed to work, it's not working, or given certain situations for certain inputs, it's not working. So debugging skills are important. So technical skills, debugging skills, right. This also gives some added mileage. For example, you know how to basically use Git and GitHub, upload your projects and use it, right? Knowledge about testing, I would say it's not essential. I will rank it a little low for a junior engineer, right? This is something which is good to have, right? Not essential, right? Maybe good to know, right? They may not be very essential. Similarly, documentation skills you can have, right? For example, whatever you do, you publish it in GitHub, right? That's the idea. Learn how to document it, right? Draw diagrams, for example. So we use something called as an SDLC process in project, right? There you learn about requirements, design, etc. So this design you have to, for example, properly explain using flowcharts, diagrams, etc. Again, this is something which you can uh, build as you do projects, right? So when you do projects, document your projects, right? So these are also good to have skills, right? Soft skills are also very important to crack an interview. So in terms of industry expectations, we are talking about technical skills, right? So we are talking about technical skills. This is number one thing, right? In technical skills, for example, you should have debugging skills, right? This is something good to have, and this is also very important. Soft skills, right? So many a time we see students who are technically good, but they don't know how to explain the project or concept which they learned. So you should build good communication skills and also have basically a good resume with you. Typically, right, we seen basically students coming with a resume from college, right? It's kind of a copy paste, right? What my friend has done, same thing you put it, right? Only the name, email ID is changed, right? That should not be the case. So as part of building a strong portfolio, have a basically good resume, learn how to explain the concepts, learn how to explain the projects, and this is definitely required to crack any interview, right? That is very, very important. So this is what companies expect from a aspirational embedded systems engineer. All right, any questions? I'm getting some more questions here. Let me check. Adiraj sir, among VLS and embedded systems, how can we decide which is a better field to build a career on? There are advantages of both, and of the fields are both good. Let me decide which one is interested, right? Again, this is a common question we get. Both are good, right? Adiraj, right? Nothing wrong with doing embedded systems, nothing wrong with doing VLSI. Both has its own basic advantages. So VLSI and embedded also have job requirements. Only thing is that compared to VLSI, embedded system has more job opportunities. Right? That is something which is very clear in terms of number of jobs available. Embedded systems has more job. But if you're really interested in basically chip design, IC design, right? It could be physical, etc. Layout design or whatever whichever area you're interested in, you can go for VLSI design, and it's a personal choice, right? That's what I would say. Okay, so Vijay Karthikeyan, have created a wearable exoskeleton for paralyzed people and prosthetic arm on my own. What job role could be perfect choice for me, right? Yeah, I think it's good to showcase the project. For example, you've shown a wearable exoskeleton, right? Whatever is there, right? Now, whether you can get a job in that related company may or may not be possible, right? That is something which a fresh engineer should know, right? So maybe I've done a project in one area. Is it necessary that I get into only that domain? Not necessary, I would say, right? Please understand that. Yes, but will give an advantage in terms of shortlisting, or some specific companies are there who is basically building an exoskeleton, right? And these are like mostly startups or companies, right, which work on those things. You can try to apply for those companies. Definitely you will get an edge over others, right? But that need not be the case always. As a fresh engineer, you can be open and ready to work in any vertical, I would say. Okay, that keep that in mind, because you may not be able to really get into an area where you're done an academic project, I would say. Okay, then some more questions. Anirudh is asking, like complete beginner to STM32. I wish you understand and program study. Can you give me some guidance on how can I start? Like if you want to learn Arduino, okay, fine. Okay, maybe I would suggest, okay, because of the limited scope of this webinar, Anirudh, you can basically send this question directly to me on LinkedIn, or maybe on the discussion forum in Moodle also. We'll try to answer it, because it's kind of a lengthy answer I may have to give. Okay. So how about networking in IoT and embedded? Yes, networking is. Sugo Wanam is asking about networking. Yes, networking in IoT and embedded is also important. Like TCP/IP protocols or protocols like HTTP, MQTT, etc., may get used in embedded systems. Sir, does embedded system play a role in medical field? Yes, Lakshmika, right? In medical domain, this is also one of the growing areas in embedded system. Medical field, lot of basically embedded diagnostic systems, right? For example, one of our companies, right? They had requirement on having a the system designed for monitoring vitals, like an ICU, right? We go to an ICU, we have this device. It senses all the vitals information, displays it, sends alerts, beeps, right, whenever there is a need, etc. Most of the medical devices are related to embedded systems, right? We also have companies which are like into embedded systems, medical field plus AI. Recently, right, we had a company who's designing a smart stethoscope, right? Doctors use a stethoscope, right? Nowadays, right, it is smart. It has AI analytics built into it, right? It will give some basically information by analyzing the information coming from that device. When we'll start building the project internship? Okay, hope it will start shortly, right? So that's what it's like. You directly don't build a project. First, you have to build the foundation knowledge, then apply it and build a project. Is there a need for learning AI for embedded systems or IoT? Okay. If so, what should be the roadmap? Dane Maha Santosh is asking. Not necessary, I would say, right? So there are many things to learn, and you can do many things without using AI also. So if your focus is on becoming an embedded IoT engineer, I would say learn the foundations of embedded IoT. Later on, maybe you can learn about the AI landscape also, like edge AI, right, etc. It's not essential initially, I would say, right? Later on, you can still leverage. Karthik is asking, sir, I'm third year. So what will you suggest to do right now, or what to learn, right? I think whatever discussion we're having is in those lines, right? You can, right, build the skills on these areas. Maybe I'll summarize it shortly also. What is the role of embedded systems? Jayaswari is asking, what is the role of embedded systems in security and cyber department, right? This is a very good questions, right? In cyber surveillance security, right? So recently, I recall I watched a interview or podcast typically by Nikhil Kamath, right? You might have seen it on YouTube. he had interviewed the police department, including the DGP and higher officials, and they one of that person who was part of the podcast was in the senior role. He, in fact, I think was coming from engineering background, but he has holds a top first in Bangalore. Right, Bangalore is famous for right many things, right, and may not be so famous, for example, for its traffic, right. And in that podcast, he in fact showed how basically IoT is involved in controlling the traffic and building a secure basically system in it, right. So simple thing could be, for example, you want to have like a monitoring system for vehicles who are breaching the basically traffic rules, right. So you can use AI cameras. Using these AI cameras, you can detect different things. For example, if I'm wearing a seat belt or not, or somebody is basically jumping the signal or not, right, etc., can be used for implementing security for road traffic control. In surveillance, for example, AI-based cameras are available, right. You can see whether somebody is noted for something. You can match it with police records, etc. In cyber security also, they are quite used, right. They're all interlinked, I would say. In cyber security in itself is a domain, and it can be linked to embedded also and IoT also. So a lot of specializations you can have in embedded systems and IoT. Okay, is there any scope for AI in embedded systems and IoT? If it's what will be the roadmap for the field? What skills we need for learn AI? Okay, yeah, AI in itself, right? Is something which is a domain in itself. But with respect to embedded systems, when you want to build an embedded AI-based system, yes, foundations of AI will help. I think many questions related to AI is coming. We'll just talk about it briefly. We don't have time much, but I'll just briefly touch upon it. Yeah. In embedded, right? So talking about AI in embedded, right? So I would say, like in any case, if you want to get into AI for anything, right? It may not be AI for embedded. It could be AI for anything. Having the core foundational AI skills are important. Right. Again, right, when you talk about AI, right, you may talk about, right, AI, ML. Again, here, for example, right, ML, you have something called a deep learning, etc. Then nowadays you use large language models, right, etc. Right. So you have to have a foundational knowledge of this first. Foundations of AI, how they work. In ML, for example, the concept related to ML, you have to learn if you're going to build basically application based on ML. But if you're going to use, right, generative AI, right, you have to learn about those tools and APIs which are available for that, right? That is one thing. And the AI landscape. This is for AI for anything, right? Then when it comes to embedded, right? So there are again multiple things here. So one thing that comes into mind is something called as edge AI. You have to learn about this, right? So in terms of edge AI, you have use a basically microcontroller and run AI algorithm inside the microcontroller, which is called as edge AI. Right? Here you have to know about machine learning, and you have to know how, for example, how you can run this machine learning algorithm on a less powerful device. less powerful device like an MCU, right? So MCUs have limitations in terms of processing capability, in terms of having a floating point unit, in terms of having a GPU, etc. So by learning about concepts related to like downscaling, inference, right, etc. with respect to MCUs, we have something called as Edge AI. And after learning machine learning at a high level, you may have to jump into Edge AI so that you can learn, okay, you have a machine learning model, how do I scale it down and try to fit in a less powerful device? For example, you take a smartwatch. The smartwatch will having a microcontroller which is having less CPU speed and less capability. Right? Can you run an Edge AI algorithm on it for detecting some anomalies like fault detection? For example, Apple smartwatch you take, right? Somebody falls, it alerts and sends an SOS, right? So that's what Edge AI is about. So there are many applications of it, right? For example, I told fault detection. Right? You can use it for industrial automation. Right? For example, in a factory, you are manufacturing many components and you want to detect whether there is a defect in that component. So you can use like algorithms based on machine learning. You capture the image of that basically component and run through that machine learning algorithm and tell whether it's a defective or non-defective device, right? That's where Edge AI comes into picture, right? So I just wanted to give only a high-level overview. In Edge AI, again, there are many things which you have to learn. Okay. A lot of questions are coming. Okay, let me run through the slides. Okay, then I'll answer the questions. All right. Yeah, I think this was something which many of you are asking. Okay, what is the curriculum mapping? What I should learn, right? Okay. Again, this is just again a broader level uh, module mapping with industry readiness. You can have several learning paths, and it's not necessary to learn everything. Right? There are certain things which are important and foundational, and on top of it, you can build specialization, and you can keep on basically improving your basic skills related to the specialization. Right? So to start with, what is required? Right? Everybody should have a strong programming knowledge, right? C and data structures, and plus if we have C++, that will also help. So by learning C programming, right, programming skills like C, C++, data structures, right, you can get into firmware development, right? Now you are a good problem solver, for example. And you're good in programming. Given a requirement, you know basically how to decompose into, let's say, modules. You know how to decompose into functions. You know how to build the functions and test it, etc. That's where the problem solving skills comes into picture. This can be independent of whether you're going to learn microcontrollers or not. A programming language along with combination of data structures is essential for any person interested to get into software development or embedded software development per se. Right? Second comes microcontrollers and peripherals, right? So that's the heart of the embedded systems, right? So again, there are several options. You can do bare metal programming, you can do RTOS based programming, etc. Initially, you can start with bare metal programming, learn about microcontrollers and peripherals. So here you'll get into device driver development and right firmware development for that given target board, etc. Right. So microcontroller and peripherals is the next skill you can build. So first is C and data structures. Second comes microcontrollers and peripheral programming. Third comes a more advanced basically module, which is RTOS or embedded Linux, right? So when you talk about more complex applications wherein you want to do multitasking, right, or multiprocessing, and there is synchronization required between tasks, right, and real-time basically processing. For example, you get some information from a sensor, you want to take real-time action. In such cases, you should know about operating system fundamentals, how multitasking can be done, how tasks can communicate with each other without breaking the system, And if it's a real-time system, you may have to use RTOS concepts to build a more robust embedded application software. So the third module I would say is operating system module. In operating system, again, there are sub modules available. One is RTOS, other is embedded Linux, right? So embedded Linux is not necessarily real time. That's the idea. And further, you can, for example, if you want to get into really core embedded systems, like for example, board support packages and board bring up, etc. Let's say device development and device driver development skills also you should have. So device driver, for example, you get a new device. Let's say a new IMU sensor is coming, which is connected using I2C or SPI, or you get a new basically Wi-Fi chipset, right, or a Bluetooth chipset, etc. Then you should be able to make that chipset work by writing a very low-level program called as device driver, right? So there, device driver programming comes into picture. So along with basically microcontroller programming, this is also a skill which you can build, right? So once that is done, let's say you want to build an IoT based system which sends information, right, from device to cloud, etc., right? Then cloud connectivity and integration comes into picture. Here is where you have to learn protocols, right? So IoT concepts comes into picture. Different protocols are there. How to get information from sensors. You may have to learn about MQTT. You may have to learn about how to configure a server on a gateway, right? You may have to learn how to, for example, send this information to a cloud server, etc. So here comes, for example, IoT gateway, IoT connectivity, then cloud setup, right? Security, right? OT updates, right? A lot of things comes into picture, right? You can learn other programming languages also like Python for scripting and so on, right? That's again a different roadmap you can have for that. So one is a roadmap which is specific to embedded, and other could be specialization related to IoT and the likes, right? So if required, these are again added basically specialization like Python and automation for test automation, CI/CD. You can use it, right? And projects, right? In the end, to showcase your resume to the client, right? You should be able to build capstone projects. It's very, very important. So build your portfolio, right? And by building projects, you are calling yourself you are interview ready. Okay, so this is kind of a complete roadmap, module level basically understanding we should have, and how it maps to a job role and industry relevance is what we are showcasing from this slide. Okay, this is a very important slide, and very well basically you can use it for your learning purpose, build a roadmap from this, and you can get into relevant basically industry based upon the skill set which you are having. Okay, hope this helps. Okay. So I know some more questions are there. Let me just quickly check. Yeah. So I wanted to show some of the job roles also, right? Let me just quickly unshare my screen and open some of the job portals, right? Just to show you that how this maps to a real job role. Give me a moment. I'll be showing some of the job posts from LinkedIn, Indeed, and the likes. Okay. Let me share my screen. Okay. So hope you can see this. Right. So these are some job postings which are available on LinkedIn. Right. So I search for embedded IoT engineer. You can search for other profiles also. I just wanted to show you. Right. Experience level we can check. Let's say entry level associate, right? Maybe junior level roles. It shows 1,000 results are there, right? Okay, let me just filter it. Right, you can see ByteBeam, right? It's a company, right? So this was posted 1 week ago, right? There are 100 plus applications, right? And here, as you can see, it's telling about ByteBeam provides all-in-one cloud backend solution for smart IoT devices, right? You can see here. Enabling business to accelerate. The platform supports data collection. That's what we were discussing about last, right? Device interaction, data analytics, over the air, OT updates, right? That's what I spoke just now, right? Roles, firmware engineer, right? The kind of a basically full-time role for firmware engineer. Skills required also you can see embedded software development debugging, right? The same thing which you mentioned the roadmap. Proficiency in ARM architecture and hands-on on software development, right? So, right, whatever we discussed, right, is what is required by the industry. This ByteBeam opening you can see, right? Again, discussed about like what are the things, right? MQTT, I used about these terminologies, right? MQTT, right? RTOS, board bring up, CI/CD pipelines, Linux, TCP/IP, and so on, right? So this is about one of the job opening, which is ByteBeam, right? So it's a good company. And let me look at the next one from Marvel. Okay, again, it's a reputed company. This opening is for C, C++, and security, right? You can see here. Okay, so it's firmware development for C, C++, right? Somebody asked, right? Oh, security is, I think this was a question asked by one of you, right? Security, does it play an important role in embedded system, right? You can, as you can see, it's all connected, right? It could be an IoT based job role. It could be a security based job role also, right? You can see that. So what are the skills required? Okay, again, Marvel is a very big company. This is one of the openings they have, right? So they work in like cloud, AI, automotive, right? These are the areas which they work on, right? And look at the kind of basically skills which they're expecting. You can see C, C++, driver development. Just now I spoke about it. Low level system programming, driver development is what you can see here, right? And some basically knowledge about cryptographic libraries are required, right? This is an added thing. Skills related to make tools like debugging, like GDB is mentioned here, right? And so on. So this is one of the other basically job roles which you can see here. Again, this opening is available in Hyderabad and Telangana, right? Let me pick some other basically companies. Let me pick up Toshiba. You can see here. This opening, as you can see, is for Linux BSP, right? Board Support Package Engineer. This comes a little low level, right? You have to have information more about kernel. It could be related to Linux, it could be related to FreeRTOS, etc., or any other RTOS, right? Opening is from Pune, right? So here again, this role requires you to have knowledge about like bootloaders, for example, right? You can see bootloaders mentioned, Linux is mentioned, build root is mentioned, right? So these are some of the basically subjects which we teach even at Emertxe now in our embedded system courses, right? Right. So you can also see, right, terminologies like Linux kernel, EC platform, right? So automotive basically applications are there. Okay. Okay. So just wanted to show you some of these job listings which are available, right? Example, look at Quest Global is again another company. This is recently updated just now 22 hours ago, right? You can see here. New basically job listing it is, right? So what are the skills required here? You can see, right? Strong proficiency in C and C++. Operating system fundamental should be there. Debugging skills are required, as you can see, right? Performance optimization, right? Such skills are required. So hope you are getting a bigger picture here, right? I don't want to basically navigate to other sites, but overall, right, you're able to see that kind of roadmap which you can look and build a career in the embedded segment, right? These are the things which you may have to learn. You have to build the skills, you have to work on projects, build a strong portfolio of projects, and you can also basically publish it in GitHub, do the documentation, build a strong resume and a portfolio, and get ready for interviews by also improving your soft skills, like improving your communication skills, learning how to explain a project in a detailed and concise manner so that the other interview gets impressed, right? These things also matters. Apart from that, you should have problem solving skills related to C, C++, etc. Because nowadays companies also focus on solving competitive programming codes. Like for example, you can solve programs on lead code, hacker rank, etc., so that you can showcase your problem solving skills also, right? So let me just quickly go to the questions if you have any. Okay, I'm just trying to see. I know there are many questions. Let me just quickly check. Keep on posting questions, I'll check. Okay, not a problem. I'm just making a note of things. Okay, I'll come back to you. Okay, so here, let me just quickly check. What kind of embedded projects stand out in interviews, right? It could be in any domain, right? It could be related to automotive, it could be related to wearables, it could be related to networking, Arshita. It could be in any areas. So important thing is to map it with an industry use case and apply the concepts which are required by the industry. Like you should use some of the concepts you learn, like you'll be using C programming, you'll be doing microcontroller programming, you'll be using RTOS, right? And we'll be connecting with the cloud. So all those skills which you learned, use them in your project and say that, okay, these skills, I used it and build a use case which is related to industry project, right? That's the idea. It does not matter which domain it is, right? But you take a real use case, see that you're applying those concepts, what you learned. That really matters. Suvarna, I want a job in this field. How many projects I have to do, right? So as I told you, right, easily, I would say around at least 8 to 10 projects you can do in this domain. Jaisur is asking, does aptitude also include in problem solving? Aptitude is also an essential skill which is required for a fresher, right? So having aptitude skills will help you to clear the first round of your interview process, right? Typically, for a fresher, companies may not directly want to like conduct an interview. They may want to apply some initial filtering, right? So how does filtering happen? So filtering happen typically is that by conducting a test. Initially, they may conduct a test which includes aptitude questions as well as some technical questions, right? So it will help you to clear the first hurdle. After that, mostly it's going to be technical questions only, right? I think I answered the question from Jay Surya. How is battery management system of EVs related to embedded? Again, it's related, but EV is again domain in itself. But you should have knowledge about microcontroller programming. Then the knowledge about battery management system is also required, right? For example, battery management fundamentals, right? Power management, etc. You should have. Then let's say you want to develop a system related to a battery management system which is integrated in your EV, or it could be a charging station is available. Then you have to use embedded systems programming also to basically facilitate the user from basically, let's say you're having a charging station, right? You should know the use cases of that. So that microcontroller programming also comes into picture. IoT also comes into picture, right? Along with battery management system knowledge. Okay, then what is this? Sugavanam, I hope I answered your question already. Okay. Is complete knowledge of data structure required? Not necessary, right? Certain essentials are required, like knowledge about ADTs, right? Linked lists, stack queues, some searching sorting algorithms, Atul, right? Etc. Time complexity, right? Trees, basis of trees. This is what is required for an embedded engineer. Okay. Sugavanam, please don't flood it. Okay, a lot of messages are getting repeated. How do projects as a second year student? Okay, that's a good question, Monisha. As a second year student, you may not have knowledge of everything. For example, as I told you initially, you have to learn many subjects, right? You can start working on C initially, try to do some project on C. Then you can learn maybe data structures, try to do a project on data structures, then microcontrollers. So take a step-by-step approach. Module you can basically do and do a project on this module. That is what is recommended. Each module you can learn, do a project on that module before building a capstone project. It's necessary that a project must be related to IoT. Not necessary, Ankita. Okay, it could be a non-IoT project also. Okay, I think Dharani, I answered this question. What level of DSA needed for embedded and IoT? Right, not like a DSA interview for your what is that software engineering jobs, right? Not that kind of a basically depth is required. But as I highlighted already, right, the things which I mentioned is important. But if you want to get into tier 1 companies, you should become an expert in DSA, for example. You want to get into Google, for example, right? Then the level of basically DSA knowledge which you have is like should be top notch. Then Adiraj is asking, I was searching for a job as a fresher in college embedded system, and most of the good companies and people have networked with the common response that companies either hire from 2+ from college placement or 2+ experience master's degree. Yeah, I think there is a general myth, Adiraj, that only, what do you say, 2+ years experience or only top colleges are getting opportunities, but that's not the case. Even freshers also have good number of opportunities. Okay, so let me show you some information as to which companies are hiring. Okay, I'll share the screen. Okay, so just to answer, I think this is one common question I'm getting, whether freshers get opportunity or not, what kind of companies are visiting, etc. This is groups.emertxe.com, which is related to embedded systems job opportunities. I just wanted to show you like what kind of companies are visiting for freshers, right? Okay, so these are some of the job applications we float for our students who are enrolled for the full-time embedded systems course and IoT course. So Infineon Technologies, I hope everybody has heard about this name, right? So this job listing is for a fresher. It's not for a 2+ years of experience candidate, right? So skill set required, it could be embedded or IoT, right? And modules completed, C, Linux internals, Arduino, Linux internals, right? You can see year of pass out criteria is mentioned, right? And academic criteria is mentioned. Then you can also see the compensation which is mentioned, right? This is for a fresher job role. The companies like Infineon is hiring for freshers. Company like Infobuild IoT, as you can see here. Let's have a look at this company, right? Multiple year of pass out students can apply, right? Salary is mentioned. Skill set also mentioned here. All the modules should complete, right? So they're expecting that all the subjects should be completed before you can apply, right? Then let me take, okay, sorry, this is a job congratulations post. Some of the students got placed recently in Ellipse Semiconductors. Let me just show you what was the requirement for that. Okay. Right, so this company specifically, if you see here, yeah, it's again a multinational company based out in US, MNC California, R&D, right? They work on wireless technologies like MIMO wireless, right? Earlier known as MIMO wireless, right? They work on like wireless technologies, right? And here branches are mentioned, compensation is also mentioned, 7 lakhs, right? So these are all opportunities which are available for fresh students only, right? It's not for 2+ years of experience, right? So freshers also have opportunities available, right? Okay, so yeah, like this, there are many companies who are like hiring from us. Recently, we also had companies like Qualcomm visiting us. Okay, so interview dates are anything getting published here. Right, companies like Siemens, right? So again, multinational companies who are hiring from us, right? Again, pass out, you can see, right? Freshers are also getting opportunities here. Compensation is for 6 to 7 lakhs. Subjects also mentioned, C microcontrollers, Linux internals modules can apply. All right. Okay. So I've answered that very important question of whether freshers get opportunity or not, right? And what are the skills that each companies are asking, etc. All right. Let me see some more questions. So please note one thing, if I'm not able to answer the questions, right, you can reach out to me on LinkedIn, right? I'll show my LinkedIn profile also. I'll share it maybe here. Okay, let me just share the URL in the questions pane. You can make a note of it. Just in case I'm not able to answer some of the questions, I will send it to you. Just typing it. So you can connect with me and I'll try to answer your queries. So did you get my message with the LinkedIn profile? Can you please confirm? In the chat box, did you get my message? Yeah, thanks for confirmation, right? So it's already 9:05. That's why I'm telling I may not be able to answer all the questions. You can connect with me. You can chat with me on LinkedIn also. I'll be happy to answer your questions there. Because many a time I may not be seeing the discussion forum, right, in Moodle, right? In your LMS, I may not be watching it often, but in LinkedIn, I'll be connected. I'll be answering your questions. Okay. Let me pick any last minute question. Okay, Atul, student from electrical and electronics engineering back. What are the subjects? What all extra subjects should I learn from? Okay, I think already mentioned. What are the subjects? Right, was already highlighted. Okay, why Linux is more important, right? Okay, this is also a good question. Linux is open source and it's quite basically suitable for developing embedded systems, right? So it's quite a versatile, scalable operating system, which is open source, highly customizable, and it's very much basically suitable for developing embedded system because it supports many hardware platforms. It has rich set of device drivers available and a lot of supporting applications and library built on top of Linux is available. Right? So it's quite convenient to develop embedded applications using Linux. Okay. All right. So I think, yeah, that's it. Any more questions you have before we end this webinar? Akash is asking, sir, EIE students are able for doing embedded system? Yes, EIE, I think instrumentation engineering, right? Yes, we can do that. We can learn embedded systems, not a problem. Okay. All right. Anything else? Any relevant questions? Okay. So We discussed, right, many things today. I'll just quickly revamp what we discussed. Then let me share the screen once again. Right. So these are the topics which we discussed for today. Initially, right, the question was asked why embedded systems and IoT matter today, right? If you see, worldwide, there has been a huge, basically, growth in the industry driven by embedded systems and IoT, right? As I mentioned, in India itself, right, there are a few millions of, basically, billions of devices getting activated and enabled for applications, right, in several domains. It could be related to automotive segment, it could be related to robotics, it could be related to agriculture, right, it could be related to healthcare, and so on. And we also discussed about what falls under embedded systems and IoT, right? We saw, right, hardware component is there, right? Firmware programming is there, right? Connectivity is there, edge is there, right? Then we discussed about applications and domain. So there are several applications areas and domain, and every, basically, domain has its own set of applications, right? We discussed about automotive industry, right? For example, ADAS is used, ECUs are there. And for example, consumer electronics, you have wearables and smartwatches and so on, right? In embedded systems has a huge real world impact, right? In the kind of, basically, applications they can serve the global sector, right? Then we discussed about two use cases. One is automotive use case, which is automotive dashboard. Then we discussed about smart wearables. We saw how the system data flow works in automotive dashboard. We also discussed how the system data flow works in a smartwatch, which is IoT enabled, right? Then we discussed about the technology stack, starting from hardware core, firmware and drivers, to communication protocols, operating system, and edge, followed by cloud and DevOps, right? These are the technologies or architecture overview for embedded systems, from silicon to cloud. Then we discussed about career roadmap, right? And learning the foundations, followed by basics, followed by foundations, then building the projects, then specialization, then becoming job ready, right? This kind of a career roadmap from fundamentals to job readiness. If you are really interested to become an embedded software or IoT software engineer, this is the roadmap which you can look up to. We also discussed about different job roles. I think I missed out on this, right? There are several job roles in embedded systems and IoT. So one can get a job as a firmware developer, or you may get a job as a driver developer or BSP engineer. There are job roles available in embedded Linux, IoT edge developer. These job roles are available. And edge AI engineer jobs roles are there. Validation and QA job roles are there, right? So it's a huge landscape. Several, basically, what do you say, job roles are there, which requires different type of skills to master, right? For example, firmware development roles requires you to know C, C++ programming, RTOS, task management, right? Building hardware abstraction layers, right? Whereas device driver and BSP engineers require to know about more about kernel, right? Embedded Linux engineers will have to know about build root, Yocto, etc., kernel customizations. IoT edge engineers will have to know about IoT related stuff like MQTT, COAP, gateway, Python, cloud configuration and setup, right? And so on. Validation and testing, engineers will have to know about, right? How do you basically do hardware and loop testing and so on. So we discussed about industry expectations, right? Then we saw that apart from having technical skills, having a strong, basically, portfolio in your GitHub profile, having debugging skills as well as soft skills are essential, right, to grab a job in the industry, right? And we also saw the mapping between modules, right? So different modules, how they are relevant to the industry, basically tech stack also we discussed, right? So overall, hope you got a complete picture of how embedded systems and IoT roadmap looks like and what you can do to build a career in embedded systems, right? If you have further questions, feel free to ask me. connect with me on LinkedIn, right? I'll be happy to answer your queries. All right. So how did you find this webinar? Any feedback, any inputs before we close? How did you find this webinar session? Was it informative? Any last minute inputs, suggestions? Yeah, okay, I'm getting messages. So thank you. So very helpful from Akash. All right. Siddharth says really eye-opening. Thank you so much, sir. Okay. Welcome, Siddharth. Welcome, Akash. A lot of questions are there. The chat messages are loading slowly. That's why I'm not able to read out the messages. So you can post your feedback about this webinar and feel free to get in touch with me later on in my LinkedIn chat as well. Surya says very useful to know what exact the industry expectations are. Thank you, sir. Okay, thank you, Jai Surya. Yeah. So Ankita says thank you for the informative session. Thank you so much. Okay, you're welcome, Ankita. Welcome, Jai Surya. All right. So with this, I think I'll stop the recording, and the recording will be uploaded in Moodle as well. So feel free to watch it, and if any queries, you can ask me in LinkedIn as well. Not a problem. Okay. So yeah, thank you all. So I hope this webinar was informative for you, and wish you all the best for your internship completion as well as your future journey. I would say internship will play a stepping stone for you, and from there you can make a decision, and we are there to help you and provide you any further suggestions. All the best to you. So hopefully everybody should be able to complete the internship and submit in your college as well. All right, have a good night, good evening, bye bye. All right, so welcome everybody. Yeah, Harshita, Satvika, Rashmika, Ankita. Right. I think you all shared your feedback. All right. I'll end the meeting now.